All right, let's continue on with our work with exponents, especially with monomials. So, two rather difficult ideas here today that I wanted to make just a separate little video on so that you could take a look at. The first one is a zero exponent. What does it mean when I have something raised to the exponent of zero? It's something different than like a single x. Single x is raised to the power of 1, right? This is not a zero exponent. That's x to the 1. That's something different, okay? That's just a single x. So let's go back to this question. Now, if I was just following my exponent laws, when I'm dividing, remember we would subtract those. So this is the case where I would actually get x to the power of 0. But what does that mean? So let's go back to what our exponents mean. So once again, I'm going to represent that one in blue. So there's 3 x's there. And we represent the bottom in green. Now it turns out, when I start doing my slashing, these all become 1s. So I'm left with 1 over 1, or 1. So it turns out, anytime I have a base raised to the power of 0, that is equal to 1. Not x to the 1, but simply the number 1. It's 1. So when I get something like this, we say that that is equal to 1. Okay. So now how does that tie in with, oops, let me get rid of that. How does that tie in with something like this? Okay. No. I like to think of this, let me just rewrite it. X squared y to the 4th over x squared y to the 3rd. Now remember what we would do here, those x's, 2 x's on the top, 2 x's on the bottom, they're going to cancel each other out. Now if I was just following my exponent rules though, I get x to the 0, y to the 1. Well, what does x to the 0 mean? It really means 1 times y to the 1, or just y to the 1, which makes sense because if I was going to expand those a long way, I would have 4 y's on the top and 3 on the bottom. 3 on the bottom would cancel with 3 on the top, leaving me with just 1. The x's would cancel out completely, leaving me with just a y. So anytime you have something to the 0 power, that's equal to just the number 1. Now, the next idea, a little more difficult again. What happens when I have a negative exponent? And here's a situation where, again, if we were just going to follow our exponent rules, we'd have x to the 3 minus 5, which is x to the negative 2. But if I was going to expand that, and I'll do it the same way we always have, 3 x's on the top, I'll represent those in blue, and 5 on the bottom, I'll represent those in green. And now let's divide those out. Anything that's common we divide out because this is just a fraction in disguise. So what happens is I've got 1 on the top and 2 x's on the bottom multiplied together are x squared. So what that means is really x to the negative 2 has to be the same as 1 over x squared. So the way that we put that, we say that if we have any base raised to a negative exponent, okay, now the key word there is any base raised to a negative exponent, okay, that's equal to the reciprocal of the base raised to the positive exponent. Right? So in other words, if I have x raised to the exponent negative 4, that's the same as 1 over x raised to the power of positive 4. Now, how does this play out? Well, there's a couple things we should be able to do with it. When I get something like this, back to a numeric base, and we ask you to simplify it, well, what does that really mean? This really means 1 over 5 squared. And 5 squared, remember 5, not 5 times 2, but 5 times 5, this would be 1 over 25. What about this one? When I have 3 raised to the power of negative 3, well, that's the same as 1 over 3 raised to the positive 3, which is 1 over 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Okay. Now what about this? When our base is not a variable, it's actually a fraction. So what's that going to look like? Right now I have 2/3 raised to the negative 2. Well, we said you take the reciprocal of the base. Well, the reciprocal means we flip the top and the bottom. So we'll get 3 over 2 squared. Well, 3 over 2 squared, we square the 3. 3 times 3 is 9. 2 times 2 is 4. So that's the way we would do that. Now, the last thing we want you to be able to do is take something with variable bases and rewrite it with just positive exponents. Now the key to remember here is the only ones you got to switch is when we have a negative exponent. Not a negative number, but a negative exponent. So when I look at this first one, the 2 is raised to a negative, the x is raised to the power of negative 2, which is a negative exponent. Y, on the other hand, is raised to the positive 3. We leave the y alone. It stays put. The x, on the other hand, moves down to the bottom and becomes x squared. So that would be rewriting that in equivalent form, which is positive exponents. Here's the second one. Negative 5, it's not an exponent. It's a number. We leave it alone. It stays there. X, what's the exponent there? It's not the negative 4. Remember, it's the 1. So it's going to stay put. The only one that's going to change is this y that's raised to the power of negative 4. So it's going to move to the denominator and be raised to the positive 4. And now I do have a negative number, but I don't have any negative exponents. So that's what we want you to work on here.